Next, let us talk about using RP2 adhesive to install PF and P series strain gauge. You know that PF and P series strain gauge is used for complete. RP2 adhesive may be used under the outdoor conditions. When you see the combinations of PF and P series against the RP2 adhesive, most likely you are dealing with the second test conditions, where you are testing the specimen outdoor under somewhat prolonged period. This is an example of the strain gauge that can be used for the purpose. Based on the coding here, you know that this is a P series strain gauge, single unit strain gauge, gauge length 60 mm, and its silence on the resistance. Therefore, the resistance of the strain gauge, it will be by default 120 ohm. The adhesive is RP2, and you're going to apply the coating material such as W1, SP tab, and also VM tab. Since now you are testing the concrete under the outdoor conditions, you will need to protect the strain gauge against the moisture. Now this W1, SP tab, and also VM tabs are all used to protect the strain gauge against the moisture. Let us look into the process. First, it will be mixing. Mixing the RP2 adhesive as per described in the adhesive instructions. Second, you will need to prepare a pre-coating surface on the concrete. We discussed about how do we apply the pre-coating by using this PS adhesive in our previous videos. You know that the purpose of the pre-coating is to provide a nice surface for the strain gauge to bond with, and also it serves as a barrier against the dampness coming from the surface of the concrete to the underside of the strain gauge. This is to prevent the absorption of the moisture by the strain gauge. Knowing that you are testing the specimen under the outdoor conditions, that means the specimen is exposed to the environment. As a result, this pre-coating is nearly inevitable. You will have to provide the pre-coating onto the surface of the test specimen. Now that you have the pre-coating surface ready, you may install the strain gauge by using the RP adhesive. Apply a thin layer of adhesive uniformly over the back of the strain gauge, and then apply a pressure until the adhesive hardens. Next, it will be bonding the connecting terminals. If you look at the type of connecting terminals, it is stated that TFY 2M. This TFY 2M is a typical connecting terminal with the rubber backing. The dimensions, the operating temperature, as well as the quantity per sheets are given here. It normally comes in one piece here, and there are 50 units of the connecting terminals per single sheet. Now you need to install the connecting terminals. In fact, we have discussed about joining the strain gauge with the connecting terminal in our previous videos. You may refer to those videos. Basically, you may use CNE adhesive to have the connecting terminal attached on the pre-coated surface, where you're going to do soldering later, connecting the strain gauge to the connecting terminal, and then joining with the lead wire. Once you've done the soldering works, you may perform an intermediate check. This intermediate check includes checking the strain gauge resistance, by using a tester in order to see the connections with the connecting terminals. Is it properly done? And then checking the insulation resistance. Since concrete is not an electric conductor, this shouldn't be an issue. The intermediate check also include checking the quality of soldering. Do not leave any protruding lead wire. Make sure that there is sufficient solder applied onto the connecting terminal, and also make sure all the flux deposits are removed. And then check if there are any problems with the connecting terminals. Once you've done the installations of the strain gauge as well as the connecting terminals, now you will need to apply coating in order to isolate the strain gauge from moisture. You will need to apply the first coating as W1. The process or applications of W1 coating we have discussed in our previous videos. You will need to cover this W1 coating over the strain gauge, the connecting terminal, the adhesive, and also the lead wire where it joins. It is not just only on the surface of the strain gauge, as any part of those, once exposed to the moisture, will lead to the influence to the measurements of the strain gauge. The coating now should extend out roughly 5 mm from the strain gauge and the connecting terminal, but should not extend beyond the pre-coating, as the pre-coating prevents the moisture coming from the surface of the concrete or mortar. You will have to keep everything in between the pre-coating and also the W1 coating. Let's say now your W1 coating extended beyond the pre-coating. That means the moisture can still enter and reach to the strain gauge through underneath the concrete surface at the regions without pre-coating, even though you have already applied the W1 coating on top of it. Moisture can still leak through in between the W1 and the pre-coating gap. Next, you will need to apply a layer of SP tape. We also talked about the applications of SP tape coating in our previous videos. The applications of SP tape coating should comprise 2 pieces. A smaller piece should be laid underneath of the lead wire, while a larger piece should be laid over the strain gauge, connecting terminal, as well as the lead wire. The SP tape laid underneath the lead wire is very important because this could be the area where the moisture can leak into the strain gauge if there is any gap underneath the lead wire. Now you cut a piece of SP tape with the size of about 5 mm. Press it down onto the side of the connecting terminal from which the lead wire extends. And then you may do some soldering of the lead wire to connect the lead wire to the connecting terminal. As you have already applied W1 over the connecting terminal, theoretically the connecting terminal has already been coated with W1 coating. It doesn't matter, as W1 coating is sensitive to the temperature. Under high temperature, beyond 60 degrees Celsius, it starts to become liquefies. You may do the soldering over the W1 coating on the connecting terminal, and the W1 coating should easily be melted during the heating of the soldering iron. After you're done soldering, you may reapply the W1 coating. Now if there is any portions of the lead wire or the connecting terminals which are not covered by the coating, you may reapply a coating of W1. Once you've done the coating for the W1, you may use the SP tape to cover up everything. cut a piece of SP tape. It should be long enough to cover the strain gauge, the solder, and press down it in place. Please take note that in order to ensure the best protections against the moisture, the SP tape will have to come in one whole piece, having the ability to cover the entire region. It should not come in several smaller pieces where you lay parts by parts, and this may be susceptible to the leakage of the moisture to contact with the strain gauge. And remember to press the SP tape down so that it's properly bound onto the coated area. You may use SP tape separating papers to carefully apply pressures to the area around the lead wires. At this stage, you will have the pre-coating laid onto the concrete and mortar, and then you install the strain gauge and the connecting terminal. Lay several layers of W1 coating over the strain gauge and the connecting terminal, and then you do some soldering to connect the lead wire with the connecting terminals. Reapply a few layers of W1 coating and then cover everything with SP tape. Make sure you have a smaller piece of SP tape also underneath the lead wire, which you can prepare upfront before you do the soldering process. Now you have covered everything with SP tape. You will need to provide a final coating by using the VM tape. Now you will need to cut a piece of VM tape slightly larger than the layer of SP tape coating and press it down in place. Again, the VM tape will have to become in one whole piece instead of several smaller pieces. This one is to ensure there is no gap or joint in between different pieces of VM tape, and properly press it down in place so that there is no gap for possible leaking of the moisture reaching to the strain gauge. Lastly, you will need to perform a final check. The final check will also consist of checking the strain gauge resistance as well as the insulation resistance, and also checking the conditions of the coating, whether it is properly provided. After that, you can proceed with securing the lead wire to the test specimen and also numbering the strain gauge. By then, your installations of the strain gauge on the concrete specimen, which is supposedly be tested outdoor, has been completed. What you see here, comparing the installation process of RP2 adhesive versus the process by using CNE adhesive, the main difference it will be the testing conditions. If the test specimen is tested indoor, normally we will expect that by the time the strain gauge is installed onto the test specimen, very soon the strain gauge should have been tested. Therefore, you have no issue by using CNE adhesive. Another advantage of testing the test specimen indoor is the environment is relatively good as compared to the outdoors. The indoor testing may not have problem with the moisture. Because of this, the coating process is not that tedious. Under some circumstances, even coating is not required for the indoor testing. Now, if you are testing the specimen outdoors, you will have concerns with the moisture. The moisture can come from the environment. It can also seep through the test specimen and reach the strain gauge from the underside of the strain gauge. In this case, the PS pre-coating adhesive is nearly unavoidable for the outdoor testing. You want to prevent the moisture coming from underneath the strain gauge through the test specimen, which at the same time you will need to use a series of the coating on top of the strain gauge in order to prevent direct exposures of the strain gauge to the moisture or water. Since this kind of testing is conducted outdoor, for better confirmations, you may use multi-layer coating. The first layer it will be W1 coating, subsequently followed by SP tab, and then the final coating it will be the VM tab. As you are doing the coating layers by layers, the process becomes more tedious, it consumes more time, and this is inevitable, as you really want a good measurements. Otherwise, it defeats the purpose of measuring the test specimens by using the strain gauge if the strain gauge cannot give you an accurate readings. Now what you see is that depending on the test conditions, the type of strain gauge being used, as well as the adhesive being used, and also whether the coating materials are required, would vary, and every single one of them has their own purposes. Make sure you do it right.